Hi everyone, my name is Eudal Ferrer and I am product engineer for protocol translators here in Intesis. Today I'm going to show you how to set up an MBus to BACnet gateway. To do so, we are going to use the Intesis MBus to BACnet protocol translator and Intesis map software. As an example, we'll try to integrate an energy meter into a BACnet system. So let's begin opening Intesis map software and then we'll click on create new project. Then we'll choose the template for evox back MBus. And finally, we'll click on the next button. Now, first of all, we have to connect to the gateway. So let's move to connection tab. Here we have two connection options, IP and USB. In this demo, we are going to use the USB option. So we'll click on USB port and then we can connect to the gateway selecting the USB port from discovered gateways list. If there is a gateway connected in this port, we'll see all the information. Otherwise, check your USB connection or try another COM port. Now click on Connect button. So now we are connected to the gateway as we can see in the status bar at the bottom. Let's move to Configuration tab. In General Settings, we can set a name and description for this project. And on Connection section, we have to set IP settings. In this case, we'll leave default values. Finally, we must choose a password for this project to protect IP connections. In this case, it will be admin. On the BACnet server settings, we can configure all BACnet settings used for BACnet integrations. Now let's move to MBus tab. Here we have four methods to create meters in the configuration. The first one is using a scan functionality. To do so, click on Scan button and here select the addressing to use. Select primary address to search meters by their primary address and select the range of the addresses to search. Secondary address to search meters by their secondary address. To use this mode, check that all connected meters support this kind of addressing. Single device mode is used when you have a single device connected to get its information. Then select the baud rate to use to search devices. You can select one or several. Then open the advanced configuration to adjust timeouts for each baud rate. To put a time interframe, to enable deep scan for secondary address scan mode, or to disable reset subcode. In general, default values should work, although we can find devices that require some adjustments in these parameters to communicate with the gateway. Sometimes you should increase timeout to give an extra time to a meter to respond to a request. In that case, select the baud rate you are using and increase the default time. Also, there are meters that need a silence time between communication frames to detect correctly the end of the communication frame. So in that case, set a time interframe. Then you can enable deep scan to do a refined scan for secondary address scan mode. The scan process will take much longer. Finally, you can disable reset subcode. There are many meters that need gateway sends the reset subcode before to respond a request from the gateway. Once finished, click Apply to save changes and finally click on the Scan button. When the scan process ends, you'll see all found devices in the meter's newly detected window. Then, if you select a meter, you'll see all its registers in the Discovered Registers window. Finally, select Devices to import in the configuration, and then select the import mode. Use Replace Meters and Signals to delete all meters and their signals present in the configuration, and add the selected ones. Use Replace Meters to delete all meters but not their signals present in the configuration. Then it will add the selected ones. Use Add Meters to add the selected ones in the current configuration. Now click on Save button to apply. The second method to create new meters is using a template. To do so, select Embass Devices node and click on Add from Template button. Here you can use your own templates or you can download from Intesis repository. In this demo, we'll use a local template, so click on Import File and select your file. Then you'll see the list of all registers in the template. Select those that you want to import and configure the device name. Finally, click on Apply button. The third method is adding a device manually. To do so, select Embass Devices node, set the number of devices you want to create, and click on Add button. Then devices will be created on the list. Finally, select each new device and configure the addressing mode and address parameters. Finally, the fourth method is cloning meters. To do so, select the meter to clone and click on Clone button. Then, on the pop-up window, select the number of devices you want to clone from this one, and finally click on Add. Then, devices will be created on the list, and you'll have to configure the address of each one. To finish Embass configuration, remember to configure Embass lines parameters. Since configuration done in the scan window was only for the scan process, to do so, select Embass Devices node and set the correct baud rate. Set if you want to do or not a continuous pooling, and if you want to make a read on start. Also, on the advanced configuration, you can manage timeout like we did on the scan window. Set a gap between pooling cycles and force meters to update the latest valid samples on start. Now let's move to Signals tab. Here we find a list of all signals in the configuration. The blue ones are signals related to the line. Then the yellow ones are signals related to a specific meter. And finally, the white ones are measure registers of a specific meter. In the line signals, we can find a general configuration error to indicate that there are one or several meters without communication. Then, force bus reading to force a new pooling cycle if we have continuous pooling disabled. Activate continuous pooling is used to enable or disable continuous pooling. And finally, bus activity indicates when there are communication frames on the bus. In the meter signals, we can find COM error device to indicate if device is communicating, force reading device to force a read of device registers, and finally, status Embass device to get information of the device status. And finally, white signals are all the registers we have been imported from the scan process. So now, if you have created a device manually, Then you will have to create all its measure registers here manually. We can do it using Add Rows button. So to create a new signal, select the number of signals you want to add and then click on Add button. Then a new row will be created. So now we'll have to activate this new signal, and on the BACnet side we'll have to set a unique name and select units if you require it. Finally, on the MBUS side, select which device contains this signal and set the register number. In that case, if you have to apply a conversion, you will have to set manually from conversions column. Now we are going to enable conversions column. Here, as you can see, we already have conversions enabled in several signals, because the scan process reads units and scale from the emitter, and then when we import the registers, maps configures the units and conversions in the configuration. Finally, since in BACnet protocol a name must be unique, we have to check each signal name, because MBUS scan uses the measure types as a name, and we will probably have several signals with the same name. So to check signals name and make them unique, we can use AutoBACName. It will put in front of the name the BACnet type and the BACnet instance of each signal. Also, we can edit them one by one from here, or we can use the export to Excel file to edit names from Excel and then import table again. Once the signals configuration is done, let's click on the Receive and Send tab. Here, click on Send to send the configuration to our gateway. Then save the configuration, and finally the process will start. When the process is done, a message will appear, and the gateway will reboot. Finally, let's move to the Diagnostics tab. Here we find a console where Maps shows information about the gateway. Then we have two protocol viewers, one for BACnet and another one for MBUS. There, Maps shows all information about the specific protocol. And finally, we find a signals viewer to see signals value, and it allows us to write commands just as we would from a BACnet client. Now let's do a test. To do that, we are going to enable the book and comms flag on the MBUS viewer. They will show us the book messages and all data frames sent and received. Now we can see when a pooling cycle starts and finishes. As we can see, now Gateway has continuous pooling enabled by their configuration. So now let's try to disable it using Activate Continuous Pooling signal. So now we have to go to Signals Viewer and write a 0 in the BACnet column of this signal. Now we can see how current pooling cycle stops and no new one starts. Now, with continuous pooling disabled, let's try to force a bus reading using the force bus reading signal. So set a 1 in the BACnet column of the signal and see how new pooling cycle starts and finishes. And finally, let's try to force a device reading using the device force reading signal. So let's set to 1 the signal and see how a new device pooling starts and finishes. So now configuration is finished and our gateway is working properly. Now, to summarize, we are going to review briefly the steps done to carry out all the configuration. So first of all, we have connected to the gateway from Connection tab. This is an optional step because we can make all the configuration offline, but here, in order to use the scan functionality, we had to connect to the gateway. Then we have moved to Configuration tab and we have configured IP settings and project name in General Settings tab. Then we have configured all BACnet parameters in BACnet Server tab. And finally, we have created the MBus meters that we wanted to read in the MBus tab. Here in MBus tab, we have seen several ways to create meters and their signals. We have seen the scan functionality and how to import meters and their signals. We have seen how to create meters from a template file. We have seen how to create meters manually. And finally, we have seen how to clone a meter. Then we have moved to Signals tab, and here we have seen how to create new signals, how to use AutoBackName to avoid repeated names, and how to export and import from Excel files. Finally, we have sent the configuration to the gateway and we have done several tests. At the end of the whole process, we have the gateway configured, communicating with MBus meters and all their available data in BACnet side, including their units as defined by the meter itself. As you could see, the process is quite intuitive and simple, thanks to Maps software. So I hope you like it, and thank you so much for your attention.